Hello guys, welcome to this brand new video, and in today's video I'm going to approximate pi. We're gonna be approximate pi, me and you, using the 1 minus 1/3 plus 1/5, and we're gonna be running millions upon millions of terms to see. We're gonna also run 100 million terms in it, and a huge surprise coming up. But let's start. So what I'm gonna do is I'm just gonna say we're gonna start with pi equals to mat.pi, just so that we know where we are. And now look at maths. Now maths is a module, and I don't have the module. But to add the module, you do control semicolon, sorry, right here, control semicolon, and then click on add import math. There it is. So now it just added this line for us. So import math and then pi equals to math.pi. Now we need three variables, I believe. So the calculated pi, I'm just gonna say calculated, and it's gonna start as 1, and then the fraction is starting at 1, 2, and I'm going to explain everything. Just follow me. And the num is 0. And now we're gonna ask how many terms the user wants. What's the number of terms? Okay, it worked. Okay, so now we have the number of terms, right? And now what I want to do is for I in range of that term. So how many terms, and add 1, because the range actually reduces 1 from your number, so just add 1. And very quick thing, if you know me, I always forget the int function. I don't know why, but I always forget the int function. But let's not talk about that. Now we have a for loop. Now what I can do is, oh my goodness, this is so annoying. Anyway, what I can do right here is we need to start. So we're gonna do an if statement. Now the thing is, this formula is 1 minus 1/3 plus 1/5 minus 1/7. So we need a way to do this, and this is where the num come from, and then from where this fraction. Actually, I'm going to set it to 3. What is this fraction? As this lower number. That lower number is actually the fraction, and I set calculated to 1 so that I can skip that fraction. I skip fraction equals to 1. So what I do now here is, what I can do is very basic. I can just say if num modulus 2 is equal to 0, then just calculate it minus equals 1 over the fraction. Now let me cover up what I did. Let me end the code first. Else calculated plus equals 1 over fraction. Okay, now I ended. So what is this? Let me show you exactly. A lot of you people will just ask, what is happening? Let me tell you. So my algorithm, you could have a better algorithm, but what I use, my algorithm, I have a number, and I keep track of this number. This number is 0. If it's even, then subtract equals 1. You see how the first term, 1, you subtract 1/3. So if it's even, then we pretty basically set I'm setting the negatives to even and the odd numbers to plus. So pretty basically, so this num, if it's even, it's a negative sign, and if it's odd, it's a positive sign. So hopefully you understand me, but right now that's it. So now what we're gonna do is this fraction should actually add by 2 each time, because we have 1/3 minus 1 minus 1/3 plus 1/5 minus 1/7. You know where we're going. And then what I can do next is I can just say num plus equals to 1. Num plus equals to 1. Yeah, pretty basically. Okay, there we go. And this is formula done, if you want to believe it. And at the end, what I'm gonna say is calculated pi. I'm going to do the calculated pi, so the hour pi. So right now I might have fooled you, but the thing of calculated pi is actually equal to calculated times 4, because in the formula, yes, we do that 1 minus 1/3 plus 1/5 minus 1/7 plus so on and so on and so on. But the thing is, we have to multiply 4 by at the end to get our pi. So now we're gonna start exploding our monitors by running 100 million terms. I'm not running a billion terms because a billion terms will take 2 minutes and I can't afford time right now, I'm sorry. But we're gonna continue. So what I'm gonna do is I'm just gonna print calculated pi. Pretty basic. And then I'm gonna print math.pi. Actually, let's print math.pi is the top. The thing is, calculated pi is always smaller than math.pi. It's pretty basically approaching pi. But the thing is, sometimes it can go bigger, sometimes smaller. I don't know. This is my theory, but if you have a different theory, just say it. Now you're gonna tell me, just do the difference. I'm going to show you, I'm gonna do the difference actually between them. Why not? Okay. Minus. So the project is done pretty basically. So we're gonna do the terminal. Do you need it bigger? No, I think this is way too big. Okay, this feels small again. Anyway, what we're gonna do is I'm just gonna run this and see what's gonna happen. So it tells us what's the number of terms. We're gonna start slow. We're gonna start with 1 term. Okay. So 3.444446. Actually, see how this is negative. So to get a positive one, number of terms, actually always try to have number of terms an even number so that you actually get the closest. Because sometimes when you stop at a negative, it isn't the full capacity. So just do even numbers pretty basically. So 4. Okay. 4 terms is very bad. Okay. 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 But now we're gonna 10 terms. We're at the tree. We actually get the tree. We need 10 terms to just get the tree. So you have 0.08. Okay. Well, I will take that. You know what? I'll take that. Okay. So now next we're gonna have 100. Okay. Now we have 0.09. What a time save. I actually got the 1 in its place. 3.1317. Okay, it's actually this whole thing is like probably nothing, like it's just some random numbers. But let's continue. Let's click run. What's the number of terms? I did 100. Let's do 1,000. I'm actually blowing up my computer. When I say it, I actually mean it. 3.1405, so 0.0009 difference. Okay, we're getting there. So 10,000. Run. And here we will start. It's becoming to crash. I don't know what is happening here. This is why we're gonna remove the difference for now. Okay. I'm just gonna remove the difference for now. I need the play button. And now let's play. We said 10,000. Okay. 3.14. 1,4. Okay, we were there. But the thing is that I see like a miracle in this. Okay, 3.141 is correct decimal places. This is wrong. 926 correct decimal places. 358 correct decimal places. And then this whole thing. But then the 3 actually is matching. I don't know how this happens. It's just a miracle, pretty basically. So we did 10,000. So now we're gonna do 100,000. I mean it when I say we're gonna go into 100 million. But right now we're on 100,000. Okay, let's run this. 3.1415. Wow. So 3.1415 and 9 and 8 are different. 265, literally 2653, and then this is wrong. 897, and then that is wrong. I don't know how this works, like literally. Okay, 1 million. I'm going 1, 2, 3, 4, 5, 6. Run. It didn't take anything. Okay, so now in 10 million, it's gonna be starting to go. It will take 2 seconds, but then in a million, 100 mil is gonna take a while. We're gonna be waiting. 3.14159. Okay, this is wrong. 6535. This is wrong. 7 is correct, and then that. So this doesn't have any miracles. Okay. Now I'm gonna do 10 million. 1, 2, 3, 4, 5, 6, 7. Okay. We're gonna wait a little bit. Bam! It worked. Okay. We passed the 10 minutes mark, so we should not take 3.14159 6 correct decimal places, 7 zeros. What is the math? Okay, so we have 2 correct. Okay, so we have this. This is incorrect. All of these for 5 are correct, and then all of these are incorrect. Okay. Now we're gonna go into the big boy, the 100 million. You have been waiting for this. It's 100 million. 1, 2, 3, 4, 5, 6. Do you want to count that? That is actually 100 million. We're gonna be waiting, me and you, until the 11 minutes cross mark, I believe. But the thing is, I believe my expectations. I have not tried this, but my expectations. What's your expectation? Comment down below. But my expectations, I wonder what. Oh, it finished! No way! Actually, in the 11 minutes mark. Okay, okay. So 3.1415926. This is wrong. 3589. Okay. So I'm sorry I wasted 20 seconds of your life for 8 digits of pi, but it's a miracle how another 4 digits is actually working. I don't know. How does these 4 the same, and then these seven things the same, and this the same? I don't know. I really don't know. I'm not doing a billion. I'm not doing a billion. But I'm going to tell you one more thing. Goodbye and have a good day.